Warm hand of welcome to the team r0ket. They didn't want an individual introduction, but maybe you get to know them during their talk about those fancy badges we all carry around with us. And here they are.
I'm Lilafish, and I will start telling you about the hardware of r0ket. Give me my first slide. Louder.
Oh.
Okay. So I will tell you first what motivated us to make the badge how it is, what is the hardware, and then how it all was produced and what happened in between. Some of you might know some of these badges. Sputnik was around at some congresses, and there you have the DEFCON badges and a hope badge. Is it better? No? Whoa! Whoa, okay. Okay, you have two DEFCON badges here, a Hope badge and a Sputnik, which was around at a Congress. What you can see, most of these have tiny cell batteries on them. That one up there and this one. Yeah. And we ourselves had some experience, a little experience with badge 2 already. We made one for the Easter egg in Munich, but it was only about 200, 300 pieces. And we already tried to involve the people as much as possible. And we had 100 kits to solder parts onto the e-Hasal, that's what it was called. And they were gone after 20 minutes. And the whole weekend we had a soldering room where lots of people were soldering 24 hours. Okay. But what we realized after the Easter egg, after an event, most of the badges end up in the drawer. You like to look at them, but there isn't really much you do with them. Also, coin cells are expensive. You never have them at hand, and they're always empty. For example, we were just for this event looking for more coin cells to be able to bring some of our e-Hasals with us, but we failed. So also, camp is very active at night too. And you want to read your name at night on your badge too, so we need larger batteries for a backlight. Also, most of those batteries were used once and they were gone, and this is not a good solution. We wanted something rechargeable, so we had a choice between very large batteries, rechargeable batteries, very large one, or a bit dangerous ones. And of course we chose the dangerous ones. Back. Yeah, also we wanted to give you the possibility to play with the badge after the event and on the event. And so we put headers on them so you can extend them with your own hardware that's down here. Here you can extend your badges, your r0kets, to make them more interesting and to play with parts you like. And we decided to only use controllers which are supported by GCC, so everyone can play with them easily. Okay, so I told you about the evil badges, because they store is only up very rarely, and camp happens a lot at night. And so we decided to use those nice lithium polymer batteries, and that's already where I can tell you about a little story. We took those from China. You have a huge choice of batteries there. You get lists with thousands of batteries. Even if you ask for a specific one, at first you get 3,000 choices which batteries you might like. And it's a bit weird if a battery producer asks you, we have charged our email address to another one. And then you ask yourself, if they say charge, do they mean change or charge when they talk about the batteries? So we didn't choose that producer. The one we chose was actually working very fine. 2 days before production, we changed some details about the battery, and it all worked out fine. They were only 10 days late, and that is what we expected from China. And they even sent us pictures from the production. On the day the batteries were supposed to arrive, they sent us pictures. Yes, they are in the last stage now. It's just 10 more days. Okay, also, we have integrated a charge controller. So whatever you do on your badge, it will be very hard to destroy your battery by playing with your badge. Okay. Yeah, everyone knows Arduino, right? Yeah, probably. We wanted something a bit more powerful and something a bit different for a change. And we heard somewhere that NXP would like or would be able to sponsor us some controllers. And of course, that was nice to hear. We didn't hear back from them for a while, and then suddenly we had a packet of 173 controllers, which was a bit weird, thinking that we were going for 3,000 controllers. And then 3 days later, we had another packet with 275 controllers. And we started wondering what might happen. Did we expect, do we have to take package every 2 days now until we have collected 3,000 batteries? No, they sent us all the batteries they had right now for samples, and they made special 500 more controllers in Malaysia, which needed some time, so they first sent us all the controllers they had already. Yeah, thank you very much. Now we have nice ARM controllers, but with only very little flash. Then we wanted a huge display, or a larger display than usual, where you can display nice text and play games. But special made displays are very expensive. Luckily, we stumbled upon the fact that Nokia makes lots of displays and many people know how to use them. And we found this Nokia, which one was it? 1200, I think. And we found lots of manufacturers in China which were making those for a few cents. And we ordered more samples of them and made a big choice, which one will we take? A good one, a not so good one, inverted one, a weird fake one, that's the one up there. And we ordered them, we sent them the money, and then the manufacturer said, oops, we just have 1,500 of these. So is it all right if we just use some displays together? Yeah, and it was already too late to start looking for a new manufacturer, so we had to take random displays. Still, they're all green, I think. We expected them orange ones in between, but that's fine. When we started out making the rocket, we had a very tiny budget, and we didn't even know if it was possible to make the thing we wanted to do with this budget. But luckily, and so we decided not to put radio on the badges and just do some infrared communication. But luckily, Milos heard about the project and told us a good dealer for the chips, which are also used in the open beacons and which are used for the attendee metadata. And last minute, 2 days before our final prototype, we changed our design, took out some stuff, and put in the radio instead. And it worked, luckily. Also, I told you about the modules, which are there to extend the rocket. They speak E²C and SPI, and you can connect lots of cool parts just directly with the E²C. And they are symmetric, so you can have something here, you can have something here, You can turn it around, and you can play with different parts. If you make the addressing of your module changeable, you can combine lots of modules. You can, I don't know, stack 10 modules and combine all the possibilities. And we already have some. We have the flame, which you can see up there, but it's already sold out. There's a magnetometer and flashlights, and also we have brought some random parts which sound interesting, and we will make those available sometime tomorrow, probably. And also there's a workshop planned. I don't know. There still has to be written some software for that, but maybe you can build your own module here. Yeah. So this, what you see, is the final design of the rocket. At first we were just very happy about all the cool hardware we had collected. We had these awesome batteries, and we had huge displays, and we had those nice controllers, and we built our first prototype, and it looked like that. Luckily, we showed this one to a friend who didn't like hardware as much as we did, and he said, yeah, I don't like it. I could just hang a mobile phone around my neck, and so we did the rocket instead. Okay, here is the first timeline we made. Just to let you know how tight everything was, we did 2 prototypes. Here's only one planned. Here's the first prototype, the only prototype in this plan still. We made it about 2 weeks earlier than planned here. We found out about making rocket in April, about April. And we are all going to university, working and doing stuff, so we weren't working on rocket all the time. And we left some weeks in the end, luckily. So we had time to do a second prototype, and we ended up having the badges right before this camp. Yeah, so the PCBs, we ordered at a German company, because lots of people told us if you order things in China, and if you have them pick and place in China, that is a bit difficult. It might not work. You might have many PCBs which won't work. And we thought, yeah, that's good. We take a German manufacturer, and they will arrive punctually, and they will be good. And then we realized they're just doing it in China themselves. And they didn't seem to know it much better than we did, because the colors came out wrong. We expected yellow. You all know what the color is, the final one. It's nice, but it's not what we expected. Also, they arrived later than the batteries. They were over 1.5 weeks, over 12 days late. And the batteries were something we added to your bags. So it wasn't important if they were here, if they were here 2 weeks before camp or 2 days before camp. But the PCBs had to be placed, had to be assembled. So if those were late, everything was going to be late. Also, the panels weren't designed very well. We thought they would know better than us and would design a stable, very nice panel, but it wasn't very nice. Luckily, we did the production at EPD, which is very close to us, and they were able to just change the date of assembly 1 week back, so we could get our PCBs from China. And of course, what was very great is it was just 1 hour from our hackerspace, so some of us got the chance to watch the assembly of the rockets and to test the first devices to find out if it was useful to put all the 3,000 parts on 3,000 PCBs. Because we did some changes on the final PCB, and we didn't really know if we made some mistakes, perhaps. But it all worked. And we have a nice video from this production, and maybe it will work too. Yeah. Okay, so here you see the room where it was assembled, and I just keep talking while the video rolls. So this is the 10 rockets in one piece. Yeah, sorry. And those are the first ones. They're put into the first machine. We started at 8 a.m., which was early. Yeah. And this is the solder paste being put onto the PCB through the stencil. And at this point, we realized there was a small mistake in the stencil. There were 4 pads which were not in the stencil. So our hackerspace, lots of people from our hackerspace hand soldered them for you a few days later. So here is an optical check. We're told several times it's micrometer exact, checking whether the solder paste is high enough. For us, this has been the first time we produced something this large, so we were all very excited, and we're still very excited about this video.
The one who filmed all this was able to open up the machine and film inside. If you're there in person, you actually can't see it that well as on the video. So
yeah, here's the first head putting parts on the machine. And those machines are going really fast. One badge took about, 10 of these badges took about 10 minutes to get through the whole way. And they were never moved by hand. They were just going around through the machines. And we were surprised to find out those machines do a lot by themselves, but they use up parts very fast. So you still need lots of people who are just putting in the parts. And what slowed down the whole process was really people who had to put in parts and didn't get after the machines fast enough. Yeah, this is cool. You can go through there, but sometimes suddenly this comes out. And what you see here, sometimes you see a red flash. That's when it does an optical check, if everything is all right. And those optical checks are quite good. They recognize if the chips, if the legs are not all the same, if some are, if the chips are not lined out right, or if the connectors are not like they should be, and things like that. They just don't pick up those parts then. This was the fastest one. It had 2 heads which were working in parallel. One was picking up the parts, and the other one was placing them. And then the one who had just picked up parts went in and put down its parts, and then the other one came back in, and so they were working in parallel very, very fast. But this optical check I told you about is not perfect. We had some badges with LEDs soldered in the wrong way, with the bright side towards the badge. But only very few. Also, they can have turned parts, so we have some weird angles to make the rocket form possible, and there were no problems for those machines. But to make those weird angles possible, people had to tell the machines lots of stuff before you could start. Before the first PCB went in, there were actually like 10 people on every machine telling the machine for an hour about all the parts it was supposed to use and how it was supposed to use them. Yeah, us too. Now it goes. Around the corner. It's also. You could walk next to one of those plates and just watch one being shifted through the machine. Now this is the oven. Before starting it, there were several test drives with temperature sensors, looking if the profile of the oven was all right for the PCBs. And I told you already, those PCBs were not very good. They were not very stable. And we had one which got stuck in there. And the next one was coming after it, and it crashed into it. And so the parts on it were shifted around and mixed up in funny ways, and they made little mountains and stuff. And then they still went through the oven and were soldered like that, because everywhere was solder paste. So now we have some rockets with little part mountains on them, which are all stuck together. And then finally, so we wouldn't have to find too many mistakes ourselves, there was an optical test to find as many mistakes as possible before giving you the rockets. I don't think I have to comment those numbers. And this is us testing the first rocket, if it would work. And we had an exciting moment because it didn't. And we thought, oh my God, no, please, not. And then we realized, oh yes, we had changed the layout. You had the on-off switch. And in the old layout, it wasn't working when you had it connected to USB. And now you have to turn on the rocket when you have it on USB, which is very practical. But we thought of that only on the last prototype. But we forgot when testing. Luckily, we remembered, and everything worked fine.
So, after all this talk about the hardware, I'm supposed to tell you something about the software side of the rocket. I hope you will find it interesting and it inspires you to hack on your own. Something about the default firmware, the one you all have, at least most of you have. There were some glitches in the flashing process. Some of you had to come visit us to get the first firmware. We had to flash them all by hand. After the production, we didn't really have much time left because, as you heard, the PCBs were late and well, everything took time. We had to solder not only 2 components where the mask was wrong, but all these connectors for your extension boards had to be soldered by hand. That's 6,000 of them. And after that, we were able to flash them. Flashing them was, at about 90% of that was done by one single person in one day by flashing 10 of them in parallel on a laptop, unplugging and plugging rockets for about, I think, 8 hours or so. More? 10? I don't know. 16 hours, sorry. Without sleep. So if there were any mistakes in flashing, I hope you can look over that. So the default firmware. It does the obvious thing, display your nickname, has lots of config options, has a config option which shouldn't be used because we put it up in the last moment, the charge LED feature. If you turn it on, the switching between night and day mode will break. So, well, we found out about that afterwards. It is a mistake in the code. But if you turn it off and reset the rocket, it will work again. We had implemented a mini mesh to transmit the time and which talks start next in the 2 lecture halls. Unfortunately, the mesh network is, well, not working as well as we hoped. And because we had size constraints on the firmware, we implemented loadable modules, which can be loaded as what you find in the execute menu. So we can extend the firmware with new functionality. And the last feature is the mass storage. There is a data flash on it with 512K of storage, and it will be visible via USB as mass storage device. It's not really mass storage, but yeah. Next slide. While writing the software, we had only 32K of flash and 8K of RAM, which is not very much. And actually, while writing the software, we ran into the limit. Mostly of the flash. The RAM was okay. Could always be more. But the processor is a 72 megahertz core, which is quite fast. So that part, we hadn't any problems with the CPU speed. We can do like 60 or 100 frames per second on the LCD if we want to. So there is that at least was no problem. And the encryption works reasonably fast. That was great. Yeah, about the mini-mesh. That's a very simplistic design, just every badge rebroadcasting everything it sees. So every badge has the same packets. There's no routing or anything done. It has different message types. One type for time-based messages, like the current time or the next lectures, and a more simple one for scores, like the Space Invader score. There's a message broadcast function to tell you to drink more water, but I don't think the current weather makes that really necessary. To avoid you tampering with the messages, the badges use a shared secret, which is in the default firmware and not really public. But as it turned out, that really wasn't our problem. The failure of the mesh is we actually don't really know why exactly it broke. The basic problem is that every badge trusts every other badge, and if one single badge has a failure, and creates a message with broken time. The other badges believe it, and well, you can't really get rid of the time. There is a feature in the mesh to reset the mesh, but that's not working if a broken badge just ignores it. I have since created a special firmware version which tests on the badge to see if it sends a broken packet and displays a message instead and halts. I flashed about 30 or 40 people with that firmware, and none of them actually hit this bug, so I don't actually know why it happens yet, but well, that's so much for the mesh. For the loadables, they are loaded into the RAM, which is quite small with 8K, and we spare about 2.5K for the loadables. The original design used 2K, but the Space Invaders got a little large, and we didn't find a way to trim it down, so we extended the loadable size just to fit Space Invaders. The first design of loadables just used some creative linker magic to make the symbols in the loadable resolve against the firmware. But it turns out every time you recompile the firmware, the symbols shift and the loadables break. And well, during development, that was really, really irritating because every time you change a single bit, all of the loadables break. And so quite late in the game, we switched to the design which uses a jump table at the beginning of the flash where symbols are exported. And we have some creative define magic in C. You can just compile the loadables like you would use the functions normally, but it used the jump table instead. Anyone who wants to look at that could look at the make table script in the loadables directory, which creates a header include file which defines all the jump table stuff, which looks really messy. Okay. And one single tidbit is that you have to get the entry point correct, and GCC likes to reorder your functions, and luckily there's a GCC switch to stop him from reordering, so the code actually starts running where you want it to. We used crypto in the mesh because that's an evil environment here, and we didn't want you to mess with the high score of the Space Invaders game. Second, the badges are also sending, if you set the privacy flag to 0, sending open beacon packets, and open beacon always in the past has encrypted their beacons, and we wanted to support that too. We kept these keys secret. To keep it secret, we enabled also the code read protection, so you can't read out the firmware. And the loadable modules, you could just write code and execute it. So we encrypted and signed the loadable modules with another key. That's if you compile the firmware yourself, this crypto part is not enabled. And it was just to see if we could, well, somehow secure this stuff. The Git repo doesn't have the keys. We will release the keys probably after the event. Okay. We have played with asymmetric crypto. The send card and receive card loadable modules do asymmetric crypto, and you can see it's a little bit slow. It takes like 1 or 2 seconds to do the handshake. So it's not really usable in the mesh code because that would be so slow. The mesh retransmit like 10 packets per second also. And for the symmetric crypto, we use XXT. If anyone wants to look it up, it's really simple. It's in the Wikipedia. Then we wanted to encourage you hacking the r0ket. We start with the simple stuff, like the attaching the lanyard a different way so it doesn't turn around all the time. The second part is, I remember that. If anyone played with the config options, there's an option to invert the display, to mirror the display, and some people just entered their nickname numbers, and so that in a mirrored way they look like another name. That's a little bit like fplets. About the mirror part, that's actually has a long history, because the first displays we got, some of them were, as you saw on Lila Fish's slide, some of them had mirrored output, and we couldn't find out why some displays were mirrored and some not, and so we put in a config options. Very late in the game, we found that our LCD initialization code actually set the mirrored flag, and some of the cheap China clones just don't support the mirrored flag. So, and when we fixed the installation to remove that, all of the displays were faced the same way, so the option is not really necessary anymore. Okay. You can modify your r0ket by adding your own font. In the Git repository, there's a small Perl script which uses GD. The module in Ubuntu has a very long name for the Perl module, which, if you run it with the -b option, outputs a binary file which you can just put onto your data flash and use as a font. It supports TTF and BDF files as input for the font. And yeah, then you can use different fonts, Comic Sans. You can define your own image or animation to display instead of your nick. You probably saw the default image, the 42. I just doodled it like 1 hour before we flashed it in GIMP. There's another script to do that and convert it to our image format. The image format is just a raw dump of how the display display data is written. You can just write one image there, or concatenate multiple images, and the animation just loops through them. If you press next, that's an example. So all this is without writing any code on your part. That's the only simple part. The more advanced part is writing own code. Just compile your own firmware. The setup instructions for macOS and Linux are in the wiki. I'm not sure if anyone has written down the Windows setup instructions, but if you use Cygwin on Windows, it's basically the same as on Linux. You have to get the toolchain to compile it, check out the Git repository, and run make in the firmware directory. The firmware you're using is called Final, and it should just build a new firmware. The chip is actually unbrickable, so whatever you do, flashing your firmware, you can always recover, so you don't have to fear any problems with it. If you flash something which is not working, you just have to hold the cursor, the stick to the left, and turn it on. Then you have to wait like 20 or 30 seconds until you go into the firmware flash mode, but then it appears as a mass storage and you can just flash a new firmware on it. The wait is actually a bug in the chip. It's documented somewhere deep down in the datasheet. It turns out they forgot to initialize one of the RAM values beforehand. If you jump into the ROM code from your own firmware, you can just write a 0 in the right place and then the wait is gone. Well, I don't know why they don't fix it in the chip. We have a simulator. Ray wanted to tell you something about that.
Yeah, hi, I'm Ray. The simulator actually is also part of the Git repository, and it was developed basically in the time where we didn't have any prototypes or very little prototypes. So people could start writing software for the r0ket without having one of the rare prototype boards. What it basically does is it compiles an application for the r0ket in a way that it can execute in a Qt environment on a normal PC. So if you have a small application which displays something, you want to try out a Tetris game or something is still missing, you can do it completely on the PC without needing to flash every time and everything, and just compile it and look it on the Qt output. I'm not really sure if it's needed today anymore. I actually found it quite usable to fast develop some graphical stuff. If it doesn't work, you don't have to flash anytime. But with the loadable, it's quite easy to try out. However, the documentation is still in the wiki, and it's possibly also a good start to see how to go to the loadables directory and everything and build stuff. It only emulates currently LCD output and the 4 LEDs of the rocket. Someone sent us a contribution, I think yesterday, to emulate also the file system calls. I'm not sure if we're able to integrate that during the camp, but possibly. So if you want to try out, for example, without flashing your badge, just to compile a few of the loadables and try them, you can do it on the PC without having to touch your badge at all. Actually, I'm just talking here. I didn't write most of the code. Most of the code was written by Boris, sitting somewhere there. So thanks to him. And so thanks for that, and have fun with the simulator also.
Yeah, we have, if you don't want to do a complete firmware, you can just compile loadables. Also in the Git repository, just plop your .c file into the loadables subdirectory, call make. It just recompiles all of the loadables. If you need new symbols exported from the main firmware, you have to write it into the exports file and run the make table script, which does all the crazy define magic. But of course, if you add a new symbol, you also have to recompile the firmware because it has to export that symbol. And it will only run with that firmware. So we try to export most of the symbols you will need, but we also may have forgotten some important ones. We are actually running out of time, so I wanted to give you an overview of the source, but well, just look at the source, sorry. And well, this is the challenge. We want you to try to crack our feeble attempts at keeping the keys secret. If the first one to come to our village with the correct mesh keys or maybe the loadable keys will win something. We don't know what yet, but genau. I heard someone was already able to get one LED to blink with a buffer overflow somewhere, but I'm not sure. Okay. We have a few fun facts, but most of them were already mentioned by Leaderfish. We had to solder like 6,000 connectors, where many people in our local hackerspace helped, and I want to thank all of them to make it possible in such a short time. Yeah, I told you already about the flashing stuff and how reliable the Chinese vendors are. One part which wasn't yet mentioned is that rooting such a PCB is really fun, or at least you have a nice square PCB and have everything rooted, and then someone comes along and it's like, wouldn't it be nice to be a rocket and just cut away half of your space to lay the traces, and it's really getting cramped. And then after you've fixed all of that, someone comes along and says, wouldn't it be nice to add an RF chip? And then you have to rip out half of the work and reroute everything again. And then we had like 2 different prototype designs, and well, it took quite some time. If you show the next slide, I think it's... Oh, that's one of our prototype rockets. You can actually see that I accidentally ripped off the USB connector. It's quite a different design. It's asymmetric, but that's what we developed on, and that is like what the Eagle layout looks out when you start routing it. All the yellow lines are the connections you have to draw, and they can't overlap. Nice game. Thank you. About the future of the rocket, that's the last slide. You should always bring them to the next events. to the Congress, of course. We will probably try to have a new firmware with less bugs and more features for the Congress ready. And we will see what to do about the mesh to get it, well, more reliable and bug-free. And if anyone has ideas on nice code, just visit us at FPLET's Village. It's basically like straight ahead there, two roads down, and we can talk about stuff. Yeah, I think we're running out of time. Do we have time for a few questions? A few. Okay, any questions? Yes? About the color display. Yeah, we wrote about there's a Nokia color display which is pin compatible with the one that's at the board. And yes, you can connect it, and there is sample code which just displays one image on it. Nobody yet wrote code to make the default firmware output anything on the display. He is the guy who wrote about it and didn't actually do any work yet. But
so yeah, that's almost right. We have a non-working implementation. So if you want to code something, we can give you the sample code which outputs the display, and you can help.
I just have one thing to ask from all of you, since if you just yell at the stage, it's not going to be on the stream or the recording. So I've got a microphone here. If you have a question, please get up, get here, talk into the microphone.
Okay.
So,
any more takers?
I have a question from the internet.
Okay.
They are asking if they can buy it.
Yeah, unfortunately, there was some miscommunication about the number of attendees. We were told that there would be 2,500 attendees, which didn't quite turn out that way. So we produced 3,000, and we had some inevitable losses. For starters, the PCB company didn't manage to ship actually 3,000 PCBs. They managed to ship like 2,700, and then they shipped like 200 more, and we still were 20 short of the 3,000. And then during the production, if you failed, and actually a few turned out to be broken here at the Congress, so we're like 2,900, and that's about the number of attendees here. We're running really low on them. If it turns out that there are spare ones at the end of the camp, we would be able to sell them, but I don't actually think there will be any spare. Sorry.
Yeah, eBay.
Are you planning to produce new ones for the Congress?
That's a difficult question. The idea came sometimes wandering in our heads, but it was very easy to give one to each attendee here. But if we would make more to sell them, we probably wouldn't get sponsored chips again. We will have to find a new manufacturer, a new assembler, whatever. And so the costs would get higher. And to make it at the low price we made it now, we would have to make again about 3,000 pieces. If we want to sell them, we will also have to start thinking about safety issues, like with batteries, for example. Yeah, if someone knows a lot about this stuff, and if someone can get us a budget, and I don't know, we can discuss this, but it's really difficult, so we don't want to make any promises. And we just want to get through the camp for now.
Take a nap and sleep, actually sleep for a few hours and not work on this badge. I'm looking really forward to it. Yeah. Any more questions?
Actually, yes. Well, I'm one of the lucky guys who owns an additional r0ket badge, or not the r0ket badge, but the flame for the r0ket badge. and I would like to know if you are producing any more of these, and if you would sell at least the extensions on the Congress, and if not, how did you manufacture those? This is really interesting to make own logos in it, to brand a flame by oneself.
The flame was actually not produced by us, but just a member of our club who was involved in the project. But I don't know, Q? There, come to the stage. He's the one who did it.
Yeah, it was actually quite easy to do the acrylic glass. I went to the Fab Lab and they had a laser cutter and you can simply cut it. It's a lot of work and time, so I'm not quite sure if we can manage that for the Congress. It would be cool, so we are actually planning to do some extensions for the Congress anyway. If it will be a flame or something else, we'll have to decide. So we'll see. Maybe I'll start a list in the wiki and we'll see how many people were interested, and let's see.
Yeah. There's a suggestion from the internet that you should do a project on Kickstarter.com so that people can spend it.
We'll see about that.
Also, there's another question. Is there any modules for sale now, right now?
Currently there are no modules that I know of. The specifications for the modules are public, so anyone is free to make them anyway.
Yeah, we have brought some parts, like I told you sometime during the talk. We have ordered some random parts which speak I2C or SPI, and we've brought, what's the English name, not breadboards, but those with all the holes in it. So you can build your own module, and you can just get some parts from us at FPET's Village. I think tomorrow we just got some from the pack station here around the corner because we forgot to order some parts. Hopefully tomorrow you can get parts to invent your own modules, and if you don't know much about designing modules, there will probably be a workshop on Friday where you can design a module which does some LED stuff and perhaps with a speaker. We'll have to see about that.
Okay, any more questions? Yeah?
I've seen some Space Invaders scores which were quite unrealistic. Did somebody already crack the network, or really people playing 10 hours a day?
Neither, at least as far as I know. It looks like part of the bug in the mesh network is that part of the timestamp leaks over into the score packet. And if you interpret the score as a Unix time key, you can actually tell when it happened.
Yeah, and on the mesh network, which is built by the homegrown firmwares, which doesn't use the encryption, actually someone obviously built a Space Invaders fake firmware that broadcasted a 23-23-23 score. So thanks for that one.
I was reminded to tell you, we brought some extra charging connectors for those people who didn't bring those connectors, even though we reminded you several times to bring them, but of course we know the standard node.
The microphone is back here.
There's another question. Where can someone find the score?
What?
Where can you find the score of
if you go to the menu messages, if you have a score in the mesh network currently, there's an invaders point select which shows the current score of the Space Invaders. If I have built a new firmware, if you build your own firmware from Git today, you have some safety checks in it which make the mesh more stable, and you will get more or less proper Space Invader score unless someone hacks them. You can, if you're interested in the mesh stuff, you can try out that firmware. If with the default firmware, you run the risk of getting some timestamp in 2038, just short of the time T overflow. I'm sorry about that.
Yes, and I have to say something more about those connector cables. They are €2, and you can get them at r0ket Village too.
Okay. I think we're going to wrap it up. If you have any more questions or want to talk, just drop by r0ket Village, and I wish you a nice evening.
Also, thank you from me for your great work, and thanks for coming here and talking about it.